Hello. Today, I am going to take several of the types of problems we've been working with over the past few weeks and throw them all into one lesson. And you're going to see something a little unusual from me. You're not going to be seeing animations flying in left and right, and you're not going to hear me explaining everything to death either. And I'm doing that very deliberately. And the reason is because in later math classes, like after Math 65, you're going to see instructors that are going to just assume that you know when you have to FOIL. They're going to just assume that you know the rules of exponents. So I am going to work through these examples relatively quickly under the assumption that you do know when you need to FOIL, when you need to apply the rules of exponents, when you need to expand using some other type of algebraic process. So a good test for you is to see how well you follow along with me. If you have a lot of difficulty following along with me, that means that you probably haven't yet memorized your rules or done enough practice problems. So what you'll want to do is go back and work more practice problems until you are able to follow along with me. One other suggestion while you're watching this lesson. If I do apply a rule and you don't know exactly what rule it is that I applied, put a big question mark next to that step in your notes so that after you've watched the lesson, you can go look at your rules and figure out what the rule was that you didn't understand at the time. So I'm going to do several examples of multiplying and dividing algebraic expressions. All right, so in our first example, we're asked to find the product of 5x squared y cubed and 14x to the fourth y to the seventh. What does it mean to find a product? It means to multiply. So the first thing we need to do is write down the mathematical expression that indicates that we're multiplying these two individual expressions. We're going to take 5x squared y cubed and multiply that with 14x to the fourth y to the seventh. Neither one of the expressions in parentheses has addition or subtraction going on, so I can go straight to my rules of exponents. I need to perform a little bit of commutative and associative properties of multiplication as well. Multiplying the two coefficients, 5 and 14, that's going to give me a coefficient of 70. X squared times x to the fourth, that's x to the sixth. And y cubed times y to the seventh, that's y to the 10th. If you don't know where the exponents come from in this simplification, you need to go back, try reviewing Candace's part of the lesson today, work some more practice problems until you can follow along with where I'm getting these exponents. Let's find the product of 5x squared plus y cubed and 14x to the fourth plus y to the seventh. So I need to multiply 5x squared plus y cubed times 14x to the fourth plus y to the seventh. Now you may be noticing that this problem is very similar to the last problem. As a matter of fact, when I was typing up this lesson, all I did was I copied the last problem and I inserted an addition sign between x squared and y cubed and between x to the fourth and y to the seventh. Well, you know what? That has huge repercussions. Because when you have addition going on in one or more of the factors in the product, you cannot immediately begin applying the rules of exponents. You have to either distribute or use FOIL or use some other sort of polynomial multiplication algorithm. Here, since I'm multiplying together two binomials, I'm just going to go ahead and FOIL. So when I find the product of the first terms, that's 5x squared times 14x to the fourth, that's going to give me 70x to the sixth. When I multiply the outside terms, 5x squared times y to the seventh, that's 5x squared times y to the seventh. When I multiply the inside terms, that's y cubed times 14x to the fourth, which is 14x to the fourth y cubed. Now, before I get to my last terms, I do want to point out something. Notice that almost mindlessly, I wrote the x factor before the y factor. That needs to become equally instinctive for you. You always want to write your factors in alphabetical order because that helps you identify like terms later on. Now, I still have to multiply my last term by my last term. That's going to give me plus y to the 10th. Quickly looking through the terms, I don't have any like terms, so this is my final simplification. Here's another, find the product. I'm going to take 5x squared over y to the negative 3, and I'm going to multiply that by 14x to the minus 1, y to the 7th, all to the negative 1. Now, I can remember being on your side of the desk, and I know a problem like this could throw me for a moment. And I'm going to remind myself that as long as I apply the rules correctly, I can apply the rules of exponents in any order I want. I know that I can go ahead and start applying my rules of exponents because there is no addition or subtraction going on inside either pair of parentheses. Because I have been doing this a lot longer than you, I probably have a little bit better instinct about which path is going to lead to my final simplification most quickly. But even if you end up taking twice as many steps as me, as long as you end up with the proper simplification, that's fine. The more practice you do, the shorter paths you will be able to find. I think the first thing I'm going to do is I'm going to apply this exponent of negative 1, because I know that I can eliminate an exponent of negative 1 if I use the fact that a raised to the negative 1 power is just the reciprocal of a. So I'm going to rewrite this as my original first factor, 5x squared over y to the negative 3, multiplied by the reciprocal of 14x to the minus 1 y to the 7th. That's 1 over 14x to the minus 1 y to the 7th. Now all I need to do is combine my like factors and make sure that all of my factors end up on the proper place in the fraction. So the 5 is in the numerator, the 14 is in the denominator. In terms of x's, I have x squared in the numerator, x to the minus 1 in the denominator. That's going to simplify to x cubed in the numerator. In terms of y, I have y to the negative 3 and y to the 7th, both in the denominator. So I end up with y to the 4th in the denominator. If you don't really understand where those exponents come from, put a big question mark there, and after the lesson, go back and review your rules. Let's find the product of two factors of 5x squared y cubed. Well, there's a couple ways that I could write two factors of 5x squared y cubed. I could literally write 5x squared y cubed multiplied by 5x squared y cubed, or I could use the fact that there's a shorter way to indicate that you're multiplying together two factors of a base, and that's to write the base to the second power. Notice that I had to put the base in parentheses to indicate that every factor in that base is being squared. Since there's no addition or subtraction going on in the base, I can go ahead and apply my rules of exponents. That exponent of 2 distributes over each factor in the base, and so that's going to give me 5 squared, which is 25, x squared squared, which is x to the 4th, y cubed squared, which is y to the 6th. And again, if you're not seeing where the 4 and 6 comes from, you need to do some more practice so that you can keep up. How about finding the product of 5x squared minus y cubed? Two factors. Well, as we just discussed on the last screen, one way we can indicate that we're multiplying together two factors of 5x squared minus y cubed is to put an exponent of 2 on the parenthesis. This time, there is subtraction going on inside the parentheses, so I cannot go straight away to rules of exponents. There are no rules of exponents that apply to bases where addition or subtraction are going on in the base. I could go ahead and write two factors of 5x squared minus y cubed in FOIL, or I could use one of my special products. One of my special products says that if you have something of the form a minus b quantity squared, that expands to a, which in this case is 5x squared, minus 2 times a, which is 5x squared, times b, which is y cubed, plus b, which is y cubed squared. Now let's use our rules of exponents to simplify each term. Distributing the exponent of 2 through the first parentheses, I get 25 x to the 4th. In my second term, I have 2 times 5, so the coefficient is minus 10. I have an x squared factor and a y cubed factor. And in my final term, I have y cubed squared, which is plus y to the 6th. Let's find the result of multiplying negative 5x squared y to the negative 3, that whole quantity squared, by itself. Whoo boy. So let's write down this expression, negative 5x squared y to the negative 3 squared, and we want to multiply that by itself. So we need another factor of negative 5x squared y to the negative 3 squared. There's more than one way I can approach this problem. The first thing I want to point out is that I can go ahead and immediately begin using my rules of exponents. I can do that because there is no addition nor any subtraction going on inside the base. I think the first thing I'm going to do is I'm going to use the fact that a times a can be written as a squared. So I can take this expression and just write down one of my expressions of negative 5x squared y to the negative 3 squared, and then I can square that expression. Notice that I used somewhat square brackets as my outside grouping symbols. When you have grouping symbols inside grouping symbols, it really can help keep track of what's what if you use different types of grouping symbols. Now I have something being squared and being squared again. That's a power to a power, so I can apply the power to the power rule and write this as negative 5x squared y to the negative 3 to the 4th power. Now I can distribute that exponent of the 4 to each factor in the base. Negative 5 raised to the 4th power. That's negative 5 times negative 5 times negative 5 times negative 5. The product of 4 negatives is positive, and 5 to the 4th is 625. X squared to the 4th is x to the 8th. Y to the negative 3 to the 4th is y to the negative 12th. But the expression is not simplified until I no longer have any negative exponents, so I need to rewrite this as a fraction. In the numerator, I've got 625 x to the 8th, and in the denominator, I have y to the 12th. Make sure you have all those steps written down, and if there were any steps that you didn't really quite follow, put a big question mark there so that after the lesson, you can go back, look at your rules of exponents, and see where that step came from. Alrighty, this time we're just being asked to simplify negative 2x squared y to the negative 3, that quantity raised to the negative 3 power. So let's go ahead and write down our original expression. And on this example, I'm actually going to write out the step where I'm distributing that exponent of negative 3 to each factor in the product, because there's something that's a little tricky here for some people. So I need to take that negative 2 and raise it to the negative 3 power. I need to take the x squared and raise it to the negative 3 power. And I need to take the y to the negative 3 and raise it to the negative 3 power. But I've made a boo-boo. Can you see what the boo-boo is? The boo-boo is that it's the number negative 2 that needs to be raised to the negative 3 power. And no matter how firmly I know that in my mind, if I don't write parentheses around the negative 2, I have not communicated that I'm multiplying negative 2 by negative 2 by negative 2, because the exponent does not affect the negative sign unless the entire base is written inside parentheses. Now I'm good to go. I see some negative exponents, which means that if I want those exponents to be positive, I'm going to have to take the expressions and move them to the denominator of a fraction. So I'll go ahead and write my fraction bar. In order for me to evaluate negative 2 raised to the negative 3 power, the first thing I have to do, I just don't have any choice, is I need to make the exponent positive. And I can do that if I move that factor to the denominator. So in the denominator, I have negative 2 cubed. In terms of my exponent on x, the exponent on x in the numerator is negative 6, and the exponent on y in the numerator is positive 9. So what do I have altogether? Well, I can see in the base I'm multiplying together three negative numbers, so my final result is going to be negative. The absolute value of negative 2 quantity cubed is 8, so I have a coefficient of 8 in the denominator. In order for that exponent on the x factor to be positive, the x factor needs to be moved to the denominator. So in the denominator I have x to the 6th, and in the numerator I'm leaving behind my y to the 9th. Let's find the product of three factors of 2y squared minus x. So the way I can easily communicate that I'm multiplying together three factors of this expression is I can write the expression in parentheses and cube it. Now the first thing I'm noticing, and I mean this quite literally, is that I have a big old subtraction sign in the middle of my base. Anytime you have an addition or a subtraction going on in your base, you may not immediately begin applying the rules of exponents. You have to think about polynomial multiplication. Well, when you're multiplying together three or more polynomials, you can only do it two at a time. So I think the first thing I'm going to do is I'm going to rewrite this as 2y squared minus x, that quantity squared, times 2y squared minus x. So I still have all three of my factors. Now I think things are going to get pretty wide here, so I'm going to go ahead and jog my equal sign a little bit farther to the left so I have some room to write. 2y squared minus x, quantity squared, that's a special product. I take my a, which is 2y squared, and square it, and then I subtract 2 times my a times my b, and then I add my b squared. And remember, this squared binomial needs to then be multiplied by my 2y squared minus x factor. So this is going to give me 4y to the 4th minus 4xy squared. Notice I wrote the x factor first completely out of instinct. You need to practice enough so that it just becomes automatic that you write an x factor before a y factor. And I still have my plus x squared. And this needs to be multiplied by 2y squared minus x. Now, do you remember how you multiply trinomials and binomials? What you have to make sure you do is multiply every term in the trinomial with every term in the binomial. Now, one way you could do this is you could distribute the 4y to the 4th over the two terms in the binomial, the minus 4xy squared over the two terms in the binomial, and the plus x squared over the two terms in the binomial. And if you choose to do it that way, as long as you do it correctly, that's great. I find it easier to organize in my mind if I distribute the terms of the binomial over the trinomial. For whatever reason, it's easier for me to keep track in that order. So that's the order that I'm going to use. You need to use the order that works for you. So taking the 2y squared and distributing it over the trinomial, that's going to give me 8y to the 6th minus 8xy to the 4th plus 2x squared y squared. Distributing the minus x over the trinomial, I'm going to get minus 4xy to the 4th plus 4x squared y squared minus x cubed. If you had a little trouble keeping up with me there, that's okay. Put a question mark and look at it again after the lesson, or pause the tape and look at it, and make sure that you are following where all of those terms came from. Now let's go ahead and combine our like terms. I only have one y to the 6th term, so we have 8y to the 6th. How about xy to the 4th? There's minus 8 of those. There's minus 4 of those. So altogether, there's minus 12 xy to the 4th. How about x squared y squared? Plus 2 plus 4, so that's plus 6 x squared y squared. And then we're subtracting x cubed. Again, one of the reasons I'm going through this so quickly is because in your later math classes, this is about the pace that you can expect, so you want to practice enough that you're going to be able to follow along. Let's do some division problems. Let's divide 5x squared y to the negative 3 by 14x to the minus 1 y to the 7th. I could indicate this division using a division symbol, but in algebra, it's always easier to work with the expression if you indicate the division using a fraction bar. So using a fraction bar, I'm going to divide by 14x to the minus 1 y to the 7th. There's no addition in this expression. There's no subtraction in this expression. So I can go ahead and just start applying my rules of exponents. I'm going to have factors of 5 and 14 in the numerator and denominator. Altogether, I'm going to have x cubed in the numerator, and I'm going to have y to the 10th in the denominator. Do you see where those exponents came from? If not, do some more practice, and later on, rewatch this part of the lesson, and hopefully you will see where those exponents came from. Holy moly! Let's divide this really long and really variable-laden expression by 5t to the 8th z squared. So the really long, really variable-laden expression is 25 t to the 8th z to the 11th minus 35 t to the 8th z to the 5th plus 45 t to the 8th z cubed, and all of that is being divided by 5t to the 8th z squared. Now, when I look at this, the first thing I'm noticing, and I do mean this literally, is that there's subtraction going on in the numerator, and there's addition going on in the numerator. And that means I cannot start applying my rules of exponents yet. If you're feeling a little overwhelmed by this problem, there's some good news in the first step of the problem. And the first step of this type of problem is to take this one fraction and using the rules of addition and subtraction of fractions, turning it into 3 fractions. And I can do that if I take every term in the numerator and give it its own personal private denominator. So let's do that. This is going to be 25 t to the 8th z to the 11th over 5t to the 8th z squared minus 35 t to the 8th z to the 5th over 5t to the 8th z squared plus 45 t to the 8th z cubed over 5t to the 8th z squared. Now, in a sense, I've taken this one massive problem and I've turned it into 3 small-sized bite problems. It might help you if you literally covered up the other 2 terms as you simplify each term. Looking just at the first term, all I'm looking at is this term right here. Now I don't have any addition or subtraction going on in the fraction, so I can go ahead and start applying my rules of exponents. So that first term, the coefficient is 25 over 5, which is 5. T to the 8th over t to the 8th divides to 1, and z to the 11th over z squared is z to the 9th. How about my middle term? Well, it's negative. 35 over 5 is 7. T to the 8th over t to the 8th, that's just 1. And z to the 5th over z squared, that's z cubed, plus 45 over 5 is 9. The t to the 8ths, once again, divide to 1. And we have z cubed over z squared, which is just z. I do want to remind you about one thing on this problem before I go to the next example. We did simplify this under the assumption that neither t nor z have a value of 0. Because if either of those variables did have a value of 0, we'd be dividing by 0, and that sends us to wacky math world for sure. Here's another example. Let's take the quantity 6x minus 2 squared and divide it by negative 3x. Now, literally, even as I was writing that down, I've got to tell you what I was thinking about. What I was thinking about was that there's subtraction going on inside those parentheses in the numerator. When there's addition or subtraction going on in the base of an exponential expression, you can never immediately begin to apply the rules of exponents. You always have to do some sort of polynomial multiplication first. So the first thing I need to do here is I need to expand the expression in the numerator. This is our binomial difference squared. I've already written out the intermediate step a couple times when you have the difference of a binomial squared. So I'm going to challenge you a little bit and do the formula in my head and just write down the simplified result. If you really can't follow along doing that, that's okay. Always write down the middle step. There's nothing wrong with that, but you'll never know whether you'll be able to do it in your head until you at least try and see if you can be successful that way. So in using my formula a minus b quantity squared, my a squared is the quantity 6x squared, which simplifies to 36x squared. My minus 2ab is going to be minus 2 times 6x times 2. So altogether I have minus 24x. And then my plus b squared is going to be plus 2 squared, which is plus 4. And all of this still needs to be divided by minus 3x. Now I need to go ahead and break this up into 3 fractions. This is 36x squared over minus 3x minus 24x over minus 3x plus 4 over minus 3x. 36 divided by negative 3 is negative 12, and we have one factor of x left over in the numerator. 24 divided by negative 3 is negative 8, but we're subtracting this expression, so that's going to give us plus 8. X over x is just 1, and then we have minus 4 over 3x. Before I leave this example, I want to remind you about something. This simplification is not a polynomial. It's not a polynomial because there is a variable of x in the denominator of the fraction even after we've simplified the expression. I also could see that this is not a polynomial if I think about this expression as minus 12x plus 8 minus 4/3 x to the minus 1. When you write the terms of your expression in the form number times x to a power, the term is not a polynomial term unless the power on x is a natural number or, in the case of a constant, 0. The reason I wrote this last expression in a little dotted box is because I want to make it clear that this is not another step in the simplification of my original problem. I was done simplifying my original problem right there. It would almost be incorrect to go on to this step because you'd be introducing a negative exponent into the expression. How about this problem? 6x t to the 5th times 2x quantity squared over negative 4x squared t to the 4th to the negative 2. The first thing I'm noticing in this problem is that in neither base is there any addition or any subtraction. So there's nothing stopping me from immediately applying the rules of exponents. Whenever you get to a problem that involves rules of exponents, there are many, many paths to correct simplifications. When Candace and Ann and I were developing these lessons, we had lots and lots and lots of discussions about the order in which you apply the rules because we're 3 different people and we consequently applied the rules in 3 different orders. What I'm going to do here on my first step is a couple things. I'm going to go ahead and simplify what's inside the parentheses in the numerator. So inside the parentheses in the numerator, I have a factor of 6 and a factor of 2. So those are going to multiply to 12. I have 2 factors of x, so that's x squared. And I also have my t to the 5th factor. And all of this is squared. Now in the denominator, on the expression inside the parentheses, there's an exponent of negative 2. I could make that exponent positive if I moved that whole expression to the numerator. So this is going to be negative 4x squared t to the 4th, that whole quantity squared. Since I moved all of my variable and numerical factors to the numerator, I don't even really need to write my denominator down anymore because the only factor I left in the denominator was an implied factor of 1, and dividing by 1 does not affect the original expression, so there's no reason to write that type of division down. Now I can go ahead and use my rules of exponents. And I think I'm going to move my equal sign to the left once again, so I have a lot of room. So distributing the exponent of 2 through the first set of parentheses, I get 12 squared, which is 144, x squared squared, which is x to the 4th, t to the 5th squared, which was t to the 10th. Now I need to multiply that by the second expression squared, negative 4 squared. Remember what that means. It means negative 4 times negative 4, which is positive 16. Then we also have x to the 4th, t to the 8th. You know, the variable parts here, that's pretty easy. X to the 4th times x to the 4th is x to the 8th, and t to the 10th times t to the 8th, that's t to the 18th. But even I'm stumped by 144 times 16. Now, if I wanted to pause for about a minute, I might be able to figure it out in my head, but I think I'm going to take a path of lesser resistance. I think I'm just going to go ahead and use my calculator. So clearing out the last calculation, what I need to do is I need to multiply 144 with 16, and that's 2,304. So that's my coefficient. Let's go ahead and divide 6xt plus 3 quantity squared by negative 4x squared plus t to the 4th to the 0. Now, if it hasn't happened to you yet, this might be the first example that I'm working that's sending you a little bit into panic mode. And what's different about this example is that there's addition going on in the denominator. And not once this term have Candace, Ann, or I talked about how you simplify expressions when there's addition going on in the denominator. And I'm going to see if there's a way around this. There is. Can you see the way around this? The way around this is the exponent that's being applied to the denominator. The expression inside the parentheses in the denominator is being raised to the 0 power. And as long as the base is not 0, any expression raised to the 0 power is 1. And whenever you're working these type of simplification problems, there's kind of an assumption there that the values of x and t are not numbers that would make this base in the denominator 0. So all of that's just a whole long way of saying that I can replace that entire expression in the denominator with the number 1. And of course, I still have my numerator, 6xt plus 3 quantity squared. Now this is a much more run-of-the-mill problem. In the numerator, I have a binomial that's being squared. How do I know it's a binomial? Because there's an addition sign, and there's a monomial on either side of the addition sign. Two-term polynomial is a binomial. Whenever there's addition or subtraction in the base, you cannot immediately apply the rules of exponents. You need to perform polynomial multiplication. I'm going to go ahead and use my special products. My special product says that a binomial sum squared is a squared. So that's going to be 6xt quantity squared plus 2 times a times b plus b squared, which is 3 squared. Applying my rules of exponents to all three of my monomial terms now, I have 36 x squared t squared plus 36 xt plus 9. Now, before I end this lesson, I do want to remind you that I know that a lot of those problems were really tough. And I also know that if I were working those problems in a classroom, I probably would have been stopped at least 179 times working through the examples. I worked through these quickly because you have a little bit of a luxury in that you should have these lessons on tape. So you can pause the tape and go and review and look at me work through the problems several times. This will really help you in the long run so that when you're in later math classes and your instructor is just assuming that you know these rules, you really will have a really good chance of keeping up with your instructor. As Candace indicated at the beginning of this lesson, We all know how challenging this is, so Candace is going to review the rules one more time in Lesson 8.
1, 2,